The water skier of mass 80 kg is towed over a straight 100-meter run of water. The tension in the horizontal tow line is constant and of magnitude 300 newtons. The resistance of the motion of the skier has a magnitude of 140 newtons. Given that the skier takes 6.8 seconds to complete the run, calculate her speed at the start of the run. Okay, so there's a skier with a mass of 80 kgs is stored over a straight 100-meter run of water. Okay, the skier is being towed. Let's say this is the skier. Its mass is 80 kg. Distance given is 100 meters. The tension in the horizontal tow line is constant and has the magnitude 300. Okay, so we're going to draw 300 newtons in the direction of the motion, which is this. Okay, the resistance to the motion of the skier has magnitude 140 newtons, so we're going to draw it in the backward direction. Given that the skier takes 6.8 seconds to complete the run, calculate her speed at the start of the run. Okay, so we have to find U. Okay, so we have the forward force, we have the backward force, and it will be equated to MA using Newton's second law of motion. So forward force is 300 newtons minus backward force is 140 equals mass is 80 kgs, and we can find the acceleration from here, which comes out to be 2 meters per second square. So A is 2. Now you can use A here. Along with these two, you can use A and use one of the equations of motion, which would be S is equals to U plus AT. So it's going to be 100 equals U plus 2 times 6.8. Sorry, the equation is V is equals to U plus AT, not S is equals to U plus AT. So it cannot be used because we do not have V. So I chose a wrong equation. So what else can be used? S equals UT plus half AT squared. So S is 100 equals U times T is 6.8 plus half times 2 times 6.8 square. Solve this, rearrange it to make U the subject, and that should get you U equals 7.91 after rounding meters per second. Okay, so this was the homework question. Those who could not do it or did not do it, I hope you've understood this question. Now we're moving on. कोई सवाल है तो please पूछो. Because I'm copying the next question from the book. I've taken pictures from the book, so I apologize if the pictures are a bit blurry. Okay, next question. Okay, I'm going to read this out to you. One horse pulls with a force of X Newton a cart of mass 800 kgs along a horizontal road at a constant speed. Now, as soon as you see constant speed in the question, what will this mean?
Mass acceleration is equal to 0.
Yes. Constant speed means acceleration is zero, which means forward force minus backward force is equals to zero because A is zero. So that means forward force equals to backward force. So there's a cart and there's forward force on it, which is X newtons. And there is a 1 horse pulls with a force of X newtons, a cart of mass 800 kgs along a horizontal road at a constant speed. Okay, this is what we're told. Then we're told that 3 horses, each pulling with a force of X newtons. So now there are 3 horses attached to the cart. This is the first system. This is the second system where there are 3 horses attached. So each of them pull with the force of X newton. And now 3 horses, each pulling with a force of X newtons, give the cart an acceleration of 0.3 meters per second square. So A is, 0.8 meters per second square. Find the time it would take 2 horses to increase the speed of the cart from 2 meters per second to 5 meters per second. Okay. Now they're talking about a third setup where there are only 2 horses. So again, each of them will apply a force of X newtons on the cart. Find the time. So you have to find T. Find the time it would take 2 horses to increase the speed of the cart from 2 meters per second, so U is 2, to 5 meters per second, which is 5, V is 5. Given that each horse pulls with a force of X newtons and the resistance to the motion has the same constant value at all times. So, and the resistance to the motion has the same constant value at all times. That means the resistance is the same here, it's the same here, and it's the same here. Okay, now we have to find A first. And once we'll have A, we should be able to use one of the equations of motion to find T. So we need A in the third case. Okay, so let's start with the first case first. Okay, so we know that there's a forward force of X newtons. We know that there's a resistance to the motion, let's call it R newtons. And we know that in the first case, the speed is constant. That means we know that the acceleration is 0. So we're going to write forward force minus backward force equals MA, but A is 0. That means forward force equals backward force. So that means X equals R. This is what we know. That the backward force has a value of X as well. So that means we can write X here and we can write X here. So the resisting force is equals to the force X. Okay, so from the first case, we have established that the resisting force is X. Now let's move on to the second case. In the second case, there is a certain acceleration. So now we're going to use the same formula, forward force minus backward force equals MA. So in the second case, the forward force is 3x. minus backward force, which is X, equals M, which is 800 kgs. We know from here, M is 800 kgs, times the acceleration is mentioned in the question 0.8. Now let's find the value of X from here. So X comes out to be 320 newtons. Okay. So that means that now we can use the third case since we have the value of X, and we can find the acceleration of the third case. So let's use the same formula here, forward force, which is 2x. Now we know what x is, by the way, so let's use 320. So this is going to be 320. This is going to be 320. And this is also going to be 320. So forward force is going to be 640 minus backward force, which is 320, equals mass, which is 800, times the acceleration in the third case, where there are only 2 horses. Okay, so this gives us 320 divided by 800, which is 0.4. Okay, so acceleration is 0.4. We also have u, which is 2. We also have v, which is 5. And we need the time. So we can use v square equals u square plus 2s. No, not that. We can use v equals u plus 80. V equals u plus 80. So v is 5. U is 2 plus 0.4 times t. Rearrange to get the value of t, which comes out to be 7.5 seconds. So अगर कुछ नहीं समझ आया तो please ask. So we were given 3 different cases. हर केस में से हमें कोई एक चीज पता चल रही है which we are applying in the next case. First case में हमें पता चल रहा था कि R is X, the resistance. Second case से फिर हमने X की वैल्यू निकाल ली, और थर्ड केस में X की वैल्यू डाल के एक्सेलरेशन निकाल दी for the third case. And then we have the 3 parameters needed to find the fourth parameter by using the equations of motion. Okay. Next question. Okay, Ji, here's the next question. A bucket of mass 4 kg is being lowered down a well at a constant speed. Okay, so let's make a bucket which is being lowered down. So that means its movement is downwards. Constant speed means that its acceleration is 0. Okay. Find the tension in the lowering rope. Okay. So you have to find the tension in the string. Okay. Okay. We've discussed already that the tension in the rope always points away from the object. So that would mean that the tension would be pointing upwards because it has to point opposite to the object. So the object is here, so it can't be pointing in the direction of the object. It has to point in the opposite direction. So it's going to point upwards. So this is the T that we have to find. Okay, and there's another force in the setup that is going to be the weight.
Miss, why does it have to point away from the bucket? Because tension is always away from the point.
Yes, yes.
Okay.
Tension always points away from the object.
Okay.
Okay. So if here's an object which is being pulled by a string, then tension would be in this direction. And if this is the object and it's being pulled by a string, then T would be pointing towards the left. It always has to point away from the object.
ठीक है, Miss.
So vertically, it needs to point upwards because downwards there's the object. Okay. Then there's another force acting on the system, which is the weight. And weight is equals to mg, as we've already discussed before. Okay. So since the acceleration is 0, so forward force, which is the force in the direction of motion, minus backward force, which is the force against the direction of motion, equals ma, but a is 0. So the forward force, which is the weight, which is mg, should be equals to the tension, and m is 4 kgs, and g in math is 10. So the tension comes out to be 40 newtons. Okay, so we found the tension. Okay, so this part is done. Okay. When filled with water, the bucket is raised with a constant acceleration of 0.8 meters per second. So now the bucket is being pulled up after being filled with water. So there's some water inside. Now it's being pulled up. So I'm making double arrows pointing upwards, showing the direction of motion. Okay. T is still going to be pointing upwards because it has to act in a direction. It has to be pointing in the direction opposite to the object. And weight will still be acting downwards, which is mg. However, now the forward force would be T because it's going upwards in the direction of the motion. And the backward force is going to be the weight since it's opposite to the direction of motion. So forward force T minus backward force mg equals ma. However, mass is not going to be 4 kgs anymore. It's going to be 4 plus x kgs because now there is water in the bucket as well. And that's what you have to find. Calculate the mass of the water in the bucket. So m now is going to be 4 kgs plus, let's call it x, where x is mass of water. The value of tension is already also given, 216. So I'm going to write 216 here. Okay. Now let's apply the values in the given equation. So it's going to be T is 216 minus mass is okay, thank you. Mass is going to be 40 plus x, not 4 plus x. अच्छा नहीं 4 ही था, sorry. 4 plus x. G is always 10 equals the new mass is 4 plus x, and the acceleration was given here 0.8 meters per second square. A was given 0.8 meters per second square. Now we solve this for x, and that's going to be the mass of water. Okay, so it's going to be 216 minus 40 minus 10x equals 3.2 plus 0.8x. Okay. Next, we can move around the constants. 216 minus 40 minus 3.2. That gives us 172.8 equals 10.8x. So 172.8 divided by 10.8. Gives 16. So the mass of the water in the bucket is 16 kgs. So you need to know that tension points away from the mass. You need to know that weight points downwards in vertical motion. And you need to know that forward force is the force in the direction of motion. Backward force is the force in against the direction of motion. And Newton's second law, which is forward force minus backward force equals ma. चलिए, इसमें कुछ नहीं समझ आया तो बताएं. Okay, then we move on.
मिस just 1 मिनट दे देना नोट डाउन.
ठीक है, sure.
ठीक है, थैंक यू मिस.